Picture this. It's 3 a.m. Your primary AWS region just went completely offline. Your CEO is on the phone screaming, asking exactly how long it's going to take to get the backup region running.
Now, if you built your cloud environment by manually clicking around the AWS console, well, your answer is probably going to be, I don't know, maybe tomorrow. Because now you have to try and remember exactly which buttons you clicked, which security groups you attached, and exactly how you configured those VPC subnets, 6 months ago?
But what if you used infrastructure as code? You literally just press enter and your entire production architecture perfectly rebuilds itself in 5 minutes. Let me show you why manual AWS setups always break eventually and why treating your infrastructure exactly like software is pretty much the only way to survive in production.
So the core mental model you really need to wrap your head around for the DVA-C02 exam is this: manual infrastructure creates inconsistency.
We call this manual approach ClickOps. You know the drill. You log into the AWS Management Console, you click Launch Instance, you click Create Database, and you click Create S3 Bucket. And honestly, it feels incredibly productive in the moment. But I'm telling you, ClickOps is a massive operational trap.
Think about it like this. ClickOps is basically like building a massive, complex Lego castle without an instruction manual. Sure, you might get it right the first time through trial and error, but if someone accidentally drops it and smashes it to pieces, you will absolutely never be able to build it exactly the same way again.
Now, infrastructure as code, or IAC for short, is that instruction manual. You write a template like an AWS CloudFormation or an AWS SAM YAML file that explicitly declares every single brick, every single network route, and every single permission. All right, now imagine this scenario. You've got a development environment and a production environment. You set them both up perfectly on day one using the console.
Fast forward a month, and a developer runs into a network bug in the dev environment. To fix it quickly, they manually open port 8080 in the development security group. Boom, the bug is fixed. But they forget to tell anyone what they did. 2 weeks later, you push that exact same application code to production, and it instantly crashes.
So why? Because of environment drift. Those two environments are no longer mathematically identical. A simple human error introduced this hidden configuration difference that literally just took down your live application.
Now, if you were using infrastructure as code, this scenario is physically impossible. To open port 8080, that developer must change the YAML code, commit it to the Git repository, and push it through a CI/CD pipeline. Your infrastructure is literally just version-controlled software.
Think about that for a second. If a bad infrastructure change takes down your application, you don't have to frantically click through the AWS console trying to hunt down the broken setting. You simply execute a git revert to the last known working commit, redeploy your template, and your environment instantly self-heals. Your entire disaster recovery strategy just becomes a simple code rollback.
Now, here's where this gets really interesting. You see, having version-controlled infrastructure isn't just about preventing outages. It's actually about operational reliability when you're scaling your team. Seriously, what happens when your company hires 5 new developers?
If you're still relying on manual setups, you basically have to hand them a 50-page Word document filled with outdated screenshots, and they're going to spend their entire first week just trying to configure a local testing environment. But if you use IAC, you just give them a single AWS SAM template. They run SAM deploy, and 10 minutes later, they have a flawless, perfectly configured exact replica of the production environment running in their own sandbox. That kind of infrastructure reproducibility is how modern engineering teams actually scale. But listen, this is where people mess up, and I'm telling you, it is a massive trap on the DVA-C02 exam. Let's say you adopt AWS CloudFormation. You deploy your infrastructure perfectly as code. But then, 3 months later, a live database issue causes a Severity 1 outage. In a total panic, a senior engineer logs directly into the AWS Management Console, completely bypasses the code, and manually changes an RDS parameter group just to get the site back online. You just poisoned your infrastructure. Because now, your code and your reality are fundamentally out of sync. Think about it. If you run your CloudFormation deployment tomorrow just to update a Lambda function, CloudFormation is going to look at the database, realize it doesn't match the template, and it might completely overwrite that senior engineer's manual fix, taking the entire site down all over again. So, to fix this, AWS provides a brilliant feature called drift detection. As an AWS developer, you absolutely must actively run drift detection against your CloudFormation stacks. It basically acts as an audit,
scanning your live AWS environment and explicitly flagging any resource that has been manually modified outside of the code. Once you actually find that drift, your job is to take that senior engineer's manual fix, write it back into the YAML template, and redeploy it.
Bottom line, your code must always be the ultimate source of truth.
All right, let's lock this down with 3 rapid takeaways. 1. Manual ClickOps pretty much guarantees human error and environment drift. You have to use infrastructure as code to ensure your development, staging, and production environments are absolutely identical. 2. IAC treats your servers and databases just like software, which lets you use Git version control to achieve team consistency, real infrastructure reproducibility, and instant disaster recovery. And 3. Never manually edit a resource in the console if it was originally provisioned by code. Always use CloudFormation drift detection to catch those unauthorized manual changes and immediately pull those fixes back into your templates.
I want to leave you with one final warning. If you're sitting there thinking that writing CloudFormation or SAM templates just takes way too long compared to clicking through the console, well, you're only optimizing for day 1. And hey, day 1 is easy. Day 100, when your database is corrupted, your servers are failing, and your entire team is panicking, that is when infrastructure as code is the only thing that will actually save your job.